Okay, so we are going to write down everything that we put on this screen because this is going to be a reference for you. You're going to use this as a reference. What are our perfect square roots? Who can give what?
144.
Okay, the square root of 144 is 12. What else?
4.
The square root of 4. Oh wait, I don't want to put it there. Is
2.
who give me another one?
Square root of 36.
The square root of what?
36.
The square root of 36.
That's the square root of 16.
The square root of 16 is 4. The square root of 100 is 10. Make sure you have all these. These are going to be your references. What else? Someone give me another one. Go ahead.
No. Wait, okay. The square root of 121.
It's what?
11.
Go ahead.
The square root of 64.
Square root 64 is 8.
Square root of 25.
Square root 25 is 5.
The square root of 81.
Square root of 81 is 9. So,
Square root of 49.
square root of 49 is 7.
Square root of 1,000.
Okay, let's keep our smaller ones. But I know where you're going. You're not wrong.
9.
The square root of 9 is 3.
Square root of 400.
Okay, let's keep them small because we don't need one that large. We don't need 1,000. We don't need 400. What other ones are missing that might fill?
Square root of 225.
If I need to figure out this one, what can I do to figure it out? Like if I wanted to find out what square root gives me 14, what could I do?
What square root gives you 14? You could do 14 times 14.
Yeah, I just do 14 times
or
itself.
14
Squares.
Yeah, square.
Which is what? 14
14
times itself.
So 14 times 140.
Okay, I like how, say it again. So Mortimer said 14 times 10 is 140, and then what are you going to do?
14 times 4
Is
16.
is 56.
Yeah, 56.
So your total is,
196.
I like how you broke it out that way. It's good strategy.
I
just-
just
All right, what other one? What square root gives us 13? 169. Good. We're missing one more.
Wait, am I counting? 1.
What?
Well, is it
What is it?
square root of 1?
Square root of 1. These are our 15, the first 15 perfect squares. Perfect square roots. Why are they perfect?
Because they're all, because they have like a perfect number, like not a decimal.
Okay, so not a decimal. Let's be more specific with the type of number that they result in. You're right, they're not
I
decimals.
forgot what it's
What kind of numbers do our perfect square roots give us? Okay, so they are, and you're right that those 15 numbers are integers. Can we go further with that? Be specific with the type of number we're dealing with right here. Okay, let's be even more specific. Let's talk about a different square root. Let's say the square root of 2. Is the square root of 2 a perfect square root? Why no?
Oh, I think so.
So the square root of 2 is not a perfect square root. Why is that one not perfect, but these 15 are? So you said they result in integers. You're right. But there's more than just the word integer that we're looking for.
Because the square root of 2's answer is a terminating decimal.
The square root of 2's answer is not a terminating decimal.
Well, I was gonna say because they're all perfect squares. Because
Why? What does that mean?
it means that like the square would make. I mean, like if you made a square right now using the information that you're given,
Okay.
they'll come out with like a perfect.
But what about them makes them perfect? You're right, and I know where your mind is going because you're actually visualizing, which is a good thing. These are perfect square roots. The square root of 2 is not perfect. Why are these perfect, but the square root of 2 isn't? We did talk about this Friday, why these are perfect square roots. Or perfect squares.
I would say because they only have 2 sides.
Why don't we have like the square root of 2, the square root of 5, the square root of 6? Why are those up there?
What's the difference between those square roots and these? You were on the right track because some of you said these are integers, these are whole numbers, but we want to be more specific with the type of number that we refer to. Because in 8th grade, we focus on different types of numbers, which we discussed on Friday, the types of numbers. What are these numbers? What did we discuss Friday? You can look back to your notes so we know you wrote the definitions down.
For rational numbers.
Say it louder. Here.
For irrational.
For irrational is one definition. What was the other definition? So we talked about irrational numbers, and then we talked about rational numbers. Okay, so why are these perfect square roots? Those numbers are what? Those are rational. Other square roots, like the square root of 2 and the square root of 5, what kind of numbers will those give us? These are perfect because they're rational. So what would the other square roots that are not perfect give us? Irrational numbers. And what do we know about irrational numbers? What do we know about irrational? They're decimals that don't repeat, and what else? They what? They don't stop. They go on forever. They go on forever and they never stop. Okay? These 15 numbers are going to be your reference. Okay, so you need to have them nearby because we're going to utilize them today. Because the goal of today is that we are going to locate approximately square roots on a number line. We're going to find what numbers, as close as possible, they are. So let's look at this number line here. Where does the square root of 2 belong? If I had the square root of 2, and I needed to place it on this number line, where would you put it? Now notice the number line that you have right now. You have 4 perfect squares. Square root of 1 is 1. The square root of 4 is 2. Square root of 9 is 3. The square root of 16 is 4. It's really like a regular number line, 1, 2, 3, 4. But on the top, we're showing those perfect squares because now we need to figure out where this would go. Where would that go? If you just placed it on the number line, around where? Where would we put it? Okay, so it's going to go between the square root of 1 and 4. Okay. So our square root of 2 is going to be a number that what? Is between, it's going to be between 1 and 2. So we're going to figure it out a little bit closer. If we put it around here, what number do we think? What could we estimate the square root of 2? Well, but let's go to the nearest tenth for now. Okay, so like 1.2. Okay, 1.2, maybe. What else could it be? 1.3. Okay, what else could it be? Maybe 1.4. How would you figure it out? Think back to the perfect squares. How'd you get the square root that gave us 14?
Maybe you can divide it. What is, I think it would be dividing by 2.
Well, it's not cutting it in half because the number squared is not the number times 2. It's the number times itself. But you gave options. You were like, well, maybe it's 1.2, maybe it's 1.3, maybe it's 1.4. How would you know if it was like 1.2 or 1.3 or 1.4? You can multiply those numbers by themselves and see what it would give you. So we're going to try it. What's 1.3 squared? This is where you multiply. 1.3. Some of you do 1.3, some of you do 1.4, some of you do 1.5. You may not need to write it out. If you have your perfect squares nearby, you could potentially make a connection with the multiplication, since that's kind of like 13 and that's kind of like 14. It's kind of like 15. You can make those connections. What do we think?
Isn't it just like 13 times? It's just 13 times 13 into 2 decimals.
So what would it be?
1.6.
So Marco's saying, if I'm multiplying 1.3 times itself, it's kind of like I'm multiplying 13 by 13, which we learned before is 169, but it's the decimal. So then we would have to add back in our decimal place values. So instead of 169, we have 1.69. So what about 1.4 squared?
That would be 1.96.
1.96. And how about 1.5 squared? 2.25. So what are we closer to? The square root of 2 is closer to what? It's in between what two numbers? So it's in here somewhere, right? Because this is 1.96 and this is 2.25, and we're looking for 2, right? Because the square root would give us that, the square root would give us that. So we're somewhere in here. Right? But notice what we did. We used our reference point, which are our perfect squares, to figure out, well, the square root of 2 has to be between the square root of 1 and the square root of 4. And then I'm really estimating here. Is it closer to 1? Is it closer to 2? And then I'm going to try some values out. Okay, so based on our estimates, this is what we have. A new number line. We're narrowing it down. Okay, so we're at the nearest tenths. Now we're going to take the square root of 2, and we're going to estimate it. We're going to go one level further. Where would it be in terms of hundredths? Would it be between 1.3 and 1.4, or between 1.4 and 1.5? Where would it be? Good, so it's going to be in here somewhere. In the middle, a little to the left, little to the right.
It would be closer to 1.4.
It's going to be closer to 1.4. Why?
Because 1.96 is only 4 hundredths away.
Right, so our number 2, we're only 0.04 away from here, but to go from 2 to 2.25, that's like 0.25 away, so we're going to be closer to 1.4. What do we think? 1.4 what?
1.41.
Maybe 1.41? Any other options? 1.45 would be right in the middle. You want it to be right in the middle? Well, Marco said we're going to be a lot closer to 1.4 because we're really close here. So maybe not over here. So what are our options? If that's 1.45, where do we think? Like 1.41?
1.41 through 1.45.
Yeah, anywhere in here. So we could try 1.41, 1.42. 1.45 is going to be too far. We've already identified it's not going to be in the middle. Okay. So the next layer would be just one step further to the nearest hundredth. The expectation is that you could estimate to the nearest hundredth. So let's try both of these to figure out where we would get. 1.41 squared. Today requires a lot of multiplication.
I just have a question.
Okay.
Is there like any other easier way that you can find some fraction?
If you use the calculator. But no, because, and we're going to talk about why after we do this and get our closest estimate. Calculator would give you the number that you're looking for, but we have to talk after we get the number what that number actually is. Because that's going to answer your question, why there isn't really an easier way. Raise your hands if you use a standard algorithm to multiply. Raise your hand if that's how you multiply. Okay. Raise your hand if you use lattice. Lattice is taught before your time.
Oh, wait,
Other strategies?
Yeah, because they yell at us.
If we don't use this and we don't use lattice, how else do we multiply? What?
The square. Wait, no, never mind.
That would be kind of,
Yeah.
okay.
We could do 1.41 times on 1, and then that times 40. What?
So it's still, you're still breaking out the standard algorithm. The reason I ask is when you came up through elementary school, there were multiple different ways taught multiple years.
Yes,
So sometimes it's, as for us teachers, we have to figure out, like my first year, all those students were taught lattice. They're sophomores in high school now. They're only 2 years ahead of you. It's transitioned. But it's helpful for us to know what way you were taught, so that if you're struggling, we can help you. Did anyone get a number for 1.41?
I got 1.9881.
1.9. Did anyone else get that? Do we need to go over how to do this?
I think we should.
Okay. I'm gonna get rid of this. Okay. It's never a bad idea to go over it. What do I do first? For those of us who use standard algorithm to multiply, again, never a bad idea to take a couple minutes and review. It's been a while. You don't work with decimals a ton in 7th and 8th grade. We focus a lot on fractions. So for some of you, it's been a while. Okay. What would I do to multiply this?
When you start like with the lowest place value, start like
Okay, so what are you gonna multiply?
the 1.
Okay, so 1 times 1, and then 1 times 4, and then 1 times 1. Okay, now what? Yeah, you guys love adding that 0. Okay. Love to add the 0. So then 4 times 1, 4 times 4. How do I do this one?
You go
For us,
6 and then you put
a 6,
And then you put the
and then the 1. Okay.
And then
5.
4 times 1, which is 4, and then 5. Okay. Now what? 2 zeros.
Bringing me back.
No, love zeros. Okay, now what? 1 times 1, 1 times 4, 1 times 1. So when we, now what?
We
We add them up. 1, 8, 8, 9, 1. And what's missing? Everything. So bring back in.
The
The
decimals.
The decimals. There's 4 of them. 1, 2, 3, 4. 1, 2, 3, 4. 1.988, 1. Where do we make mistakes when we do this? The standard algorithm for multiplication. Where are the mistakes often made? The placement of what? Okay, the placement of the decimal. What else? And this is kind of helpful because for those of you who do make mistakes doing this, it identifies why.
Like where to start. Like, you know, you have to put a zero somewhere.
Right, so that ends up being an error as well. For sometimes when people multiply like this 4 times this 1, they put the 4 here, not realizing that it's not 100th. If you're multiplying 4 tenths, then it actually would be in the tenths place value. That's another one, another common error. And then also I find, and really because if you don't use a strategy like this, it gets a little fuzzy. So even like when I do this sometimes, the 16, 6 with like the 1, some people do like the 6 and then like the 1 there. That's another, I see that as an issue sometimes. But regardless, we have 1.9881. Did anyone do 1.42? What did we get? Okay, so here we are. Woo, we did it. What would we estimate now? Okay, so at this point, you are not going farther than the 100th. The expectation for 8th grade is the 100th, that you could estimate to the nearest 100th. So where are we closest to?
We're closest to 1.41.
1.4.
Because it's 2 lineage. And since it's 1.98,
Okay.
that means 2 is only like 200 away, but if we go even further, it's still kind of like a couple away from 1.1.
So let's look at really how close we are. How far are we from 2? 0.01 what? 81. How do I get to the next 100? And from 2, how far am I?
0.6.
Okay. So where am I closer to? Yeah, so I'm like closer to here. So I can estimate that that would be my square root of 2. Now I keep saying the word estimate. Why am I estimating? We could keep going. You could do 1.414 and 1.415, but you'll never get an exact number. Why not? If I'm trying to find the square root of 2, why will I never find an exact number? Because it's an irrational number, which means it never stops and it doesn't repeat. So you would not go on forever. Some people do, they're mathematicians. Like pi, we know over 1 million digits of pi. I'm going to show you guys a video tomorrow. But we know over 1 million digits of pi, and there is no end, so it keeps going, and the numbers never repeat. There's no pattern. But for 8th grade, you're really only expected to get to the nearest 100th. But let's recap how we did that. Okay. And before we do that, let's just talk about the square root of 2. It cannot be represented as a terminating or repeating decimal. It can't be written as a fraction. It is irrational. You don't have to write this definition. You already have the definition for what an irrational number is. Okay? But we're going to try the square root of 3. But before we do that, let's recap where do we begin? How are we going to figure out where this belongs? Like, how do I know where this would go? What is my reference? The square root of 3. Where do we think it is? Around what? Less than. So you're giving me approximate areas. What are our reference points when it comes to square roots? Like, how do I know the square root of 3 isn't 10.1639778? How do I know that?
The perfect squares.
Okay, I know perfect squares. What perfect squares around 3 do I know?
Square root of 4.
Alright, I know the square root of 4. And what is the square root of 4?
2.
It's 2. And then what? So I know it has to be what? My number is going to be less than, it's going to be less than 2. So it's somewhere here. But it's not as little as what?
1.
Yeah, it's not as little as the square root of 1. It's somewhere in here. So these are our reference points, and you'll notice that later on, if you have the square root of 74, you can figure out what two integers it's between. Because you know your perfect squares from 1 through 15. And if you needed to go farther, you could. But once I have this range, what do we do now? What would we do from here?
3.
You try to locate it. And the questions are, what questions would you ask yourself as you're looking at this? If I need to place the square root of 3 on that number line, what questions should I be asking, like based on where to put it?
Is it closer to 4? Is it near the
Yeah, is the square root of 3 closer to the square root of 4? Is it closer to the square root of 1? Is it right in the middle? Right, those are the general questions. And then once you decide where it belongs, how do you start to prove it?
You can start either finding the decimal of it, like finding the decimal that you think is more correct, and doing it by the power of 2.
Yeah, so you can estimate what decimal you think it may be and prove it. Square that number. Now, Mortimer asked before, is there an easier way to do this? And I laughed and said, yeah, if you use a calculator. But besides a calculator, you're not going to be able to find the approximate number because they're irrational. You can definitely know the area that they fall, but without a calculator, and even then, you're not being given an exact value because there is none. Even then, you're not given the exact. So you're doing as much approximation as possible. And the tough thing is, we were laughing about it this morning, all year long. When we solve systems and when we solve equations, we say, don't guess and check. And now we're doing a topic where you're supposed to guess and check. So it's a little contradictory, we know. But this is really the way, and it's kind of like a standalone topic. In 8th grade, it doesn't really mesh with a lot of other stuff, which is why we do it now, right before the break. It's a small mini unit. We do it when we turn repeating decimals to fractions, and then we move on into more algebra. But when you have this reference point, you try to locate it and then find as specific as possible. Now, we go to the nearest hundredth. For those of you who love this, if you really want to try to go to the nearest thousand, you could. There was students in the first class that they just kept wanting, they're like, can we keep going? Sure, if you really want to. You don't have to. You'll never find the end because there is none. Okay. So let's work, you can work together. Find your approximate value for the square root of 3.